Okay, last time we already done for the NPN transistor. And we're talking about DC bias. Okay, make sure when you're looking into the schematic, able to recognize is it an NPN transistor or PNP transistor. That's the first step. The second step is the current. They get IB, IC, and IE. The base current, admitter current, collector current. Okay, for each NPN, PNP, how the direction of the current flow. And also field formula. Not much, okay? Then you're able to try to remember. This is the beta here. Equal IC divided to IB. That basically that's the current gate of the transistor. Okay. And also, when we're talking about I want the VB, the voltage at the base, if you have to using the meter to measure, that means the voltage connect, high side connect to the base, low side will be connect to the common, the round. Or the same thing for VE. Collector voltage will be connect from E to the round and also VC, okay? However, if they say, I want the VBE, then your meter high side will be connect to the B and a low side connect to the E, okay? That's a very, very basic, you must know. This is physical care. This is telling you we get the transistor basically NPN, PNP, and you can see that you get a two diode, one from B to the collector, one from B to admitter. Okay. This testing, anyone try it? If it's not, we don't care now. Okay.
I tried it. It's supposed to read 0.
Supposed to be 0.
It's an open circuit or open circuit, not 0. Open circuit.
That means you're talking about connect.
When you do a reverse bias.
Up here.
Right.
So basically, normally the display, they will be normally
0.7 for forward, but if you reverse it, then it's open.
Right, they're supposed to be reverse bias.
Right.
Okay, so basically, this textbook is not a good one.
Yep. Okay.
I don't know how they can get that. I already know if you measure reverse bias, diode inside they open. Okay, they're supposed to get the high impedance, and now you measure the voltage. Okay, so that's why. And now we're talking about DC bias. What that mean? That means they're using the power supply, DC power supply, to make the transistor working. The transistor basically they're using for amplifier. or some for the build logic circuitry. However, first thing, in order for the transistor to be working, they need the DC power. Okay? For this circuitry here, they need two power supply. One connect to the collector, one connect to the base. Okay? And we're supposed to able to calculate the IB, IC, IE, or VB, VC, VE. Okay? That is what we're talking about, DC bias. Without DC bias, okay, they cannot work it. Okay, so basically this using two power supply, okay, and we don't want this circuitry. The thing is, they need two power supply. You understand, power supply cost more money, okay? However, we still given to you. How do we calculate it? But we not go into detail on this. Make sure you get the problem, okay? Just bring it up. You have to really understand that's the basic for technician, okay? And also in here, remember, the operation of the transistor, they can be cut off, they can be active, or they can be saturation, only three, okay? What the cut off, they're using the switching application, like switch turn on, turn off. And the same thing happen in the saturation, okay? Normally, transistor in the saturation, they're using to build the logic circuitry in a digital circuit. And in electronic, we will deal with the active. That will be for the amplification, for amplify. That means they amplify your voice. Last one, breakdown. Breakdown, we don't want that. That will be destroyed. The transistor. That means sometimes you connect power too high. They will be cooked the transistor. Okay. And also a little here, they try to explain to you what happened at the cutoff active region or saturation. Okay. But it's not the problem. Okay, this is just a basically calculation. We already get through it. Now the DC load line. This is what they call DC load line. And basically, when you're looking into this graphic here, this stands for the current IB. IB, 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 IB. That means IB equal 20 microamp or 40, 60, 80, 100 microamp. And this horizontal using for VCE. That means the voltage from collector to the ammeter. And this stands for IC. Okay. So basically, why do we need that load line? Normally, that's for designer, not for technician. But in general, you need to understand when they design the transistor, for what purpose? They want to be amplified, or they want to be designed for the logical circuitry. Okay, then they have to know what the current IB, okay, VCE, and the IC. So in this graph in here, the first region right here, that will be a cutoff. Easy to understand cutoff region. That means transistor not working, not IB0, IC0, IE equals 0. And the area here, that for the saturation. That means if you want to design the transistor to be using as a logical circuitry, then you have to pick the point right here inside that. And in this area here, that for amplification, they want to design amplifier. So that's why normally they can draw the line. Okay, that's what they call a load line. They just draw the line. And this cut the,
Mr. Pham,
yeah.
couldn't Miss L let her in? She's waiting on the Zoom.
Oh,
Thank you.
oh, too many people. Okay, thank you. Some student, I couldn't recognize the name. They put the name, really, I cannot recognize. So next time, I will be block it, okay? You have to put your first name, last name. So Sam should know who.
Sorry, I'm late.
That's okay.
Thank you.
You already know everything. Okay,
No.
when you get a point here, okay, that's what they call a Q point. So if you're looking on this point, you know, you want the transistor IB equal 40 microamp. And you going down here, you get the VCE, and you go to the left, you can get the current IC. So now easy to design. You can using the simulation program. Only thing what you need, changing value of the RB, RC, or RE to get the current you want and the voltage you want. Okay, but that's for designer. Engineer, they have to do. We don't have to. But we just know on the basically what we need the DC load line, and that's how to draw DC load line. Okay, on this one, also they can telling you if they cut off the open switch. Okay, open switch, that means the diode will be open, so no current flow. And this is the saturation, okay? And you still get the current flowing. However, when they is saturated, like they close the switch V from the C to E, almost zero. Okay, that is for saturation. And this circuitry we already calculate last time. Okay, so if you still get confusing, then let me know. Otherwise, you're supposed to know how, but that not practical circuitry being used. Any designer, they not using. And it also given to you a different way to bias the transistor. That's what they call emitter feedback bias, and they already showing you. This is better than base bias. Q point still be moving. That's what they don't want, and not popular. Okay, so you see that one, you know, this is the emitter feedback. That means from emitter going to the base. And that's another one, base bias. Okay, the lead predictable. Q point move with replacement. Q point also move with the temperature. And also this is not practical. Okay, and the next one, collector feedback. Okay, you can see finally they say limited application. That means normally you're working on the circuitry, do not see this kind of the circuit. Two power supply bias, that we don't want either. Why? They need two power supply. That's what they not try to design. Okay. Same thing here. So that's why normally on the test or the quiz, I never using this kind of circuitry. This is the one you have to really understand. Every time you see the transistor circuitry, they using what they call voltage divider bias. Why they want this one? First thing is they need only one voltage. Okay, VCC. In order to supply the voltage for the base, they using two resistor R1 and R2 voltage divider. So VBB equal VCC times R2 divide R1 plus R2. That's what you get the voltage at the base. And you understand the resistor only 5 cents each, really cheap. Okay, so that's why this circuitry, most of the time, you can see in the schematic. Now, in order to calculate the VBB, you're using voltage divider here. Okay, after you get the VBB, you want the VE, the difference between the base and the emitter. You get a diode here 0.7 volt. So if you want to get the VE, that means you take the difference between VBB and 0.7. That's what we given to you here. Okay. After you get the VE, easy to calculate the current IE. Okay. IE equal VE divided to RE. Okay. And after you get the IE, you can calculate the IB using this formula. IE divided to beta plus 1. Okay, then you know how to calculate the IC equal beta IB. VRC, that means the voltage drop across the RC. Okay, that means you take a IC times RC. And after, if you want the VC, that means the voltage from collector to the route, okay? Then they can get VCC minus IC times RC. That means the difference from here to this voltage here. You have to see how much they drop in here. Then the leftover will be VC. This formula are using all the time. Okay? Any question?
Is there a ratio between R1 and R2?
What do you say about R1, R2?
Is there a ratio such as, say, R2 has got to be 10 times bigger than R1?
Okay. That doesn't matter.
Okay, thank you.
Depending on what the VBB they wanted. The thing is when you design the circuitry, you have to know what the VBB you wanted. Then you can select R1 and R2. Okay. Now, this one, who already done for calculation. Okay. I need to recording here. So make sure someone not done it, they can able to watch the video so they can try to find out. This is do must be done. Okay. What VBB? Who done it? Let me know. Not anyone do it anything. Okay, to get 10. Let's see, 10 plus 5, 6.
VBB is equal to 5.6 times 10 divided by 10K plus 5.6K.
The formula we already know. I want the answer.
Oh, okay.
3.6.
That just says 3.6.
Correct, 3.6.
This thing, this kind of circuitry, I want you to do without looking into any formula. The thing is, you interview, they not let you bring anything with you. So you have to exercise until you can do without looking into any notebook, any document. Who get the answer for number A?
3.6.
Who else? The thing is, when I still asking, that look like I get a different answer. I try again. How come I still get that wrong?
3.6, yeah.
You say 3.6. That means you take the 10 times 5.6. Okay. Okay. 3.6, right? I think I know wrong. I got I'm wrong.
Yeah,
It's slightly bigger than a third of the voltage, so it's 3.6.
Okay. VE.
2.9.
2.9.
2.9, yes.
IE.
5.18.
5.18, correct. IB.
5.18. Sorry. IB. No, sorry.
Zero 0.05.
Yeah, 0.05, right?
0.05, yes, 0.05.
or 51.8 milliamp.
IB 0.05. If you get the difference, then you bring it up until right now. You get up to IB. I see.
5.13.
5.13, correct. I'm not put the unit, the thing we already telling you what unit we want. VRC will be IC time RC.
Five 5.13.
Right, 5.13. VC equal VCC minus IC time RC. So 10 minus 5.13.
4.87.
4.7.
4.87.
4.87 volt. VCE. VC minus VE. VC is a 5.13 minus 2.9. Is it 5.01?
I at one point. It's VC.
Oh.
VC should be 4.87.
Yeah. I'm sorry.
4.87 minus 2.9.
Okay, what you get?
It's 1.97.
4.87 minus 0.7. Oh, sorry. 4.2.9.
1.97, I believe.
7 minus
Did somebody say 1.97?
4.97.
1.97.
One.
Okay, let's see. 1.97, right?
Right.
How come I get so wrong? I see. 4.87 minus 2.9. Yeah, 1.97. Okay, any question on this problem? Anything confusing, anything not clear, bring it up. The thing is you have to deal with it all the time.
Hey, can you explain how you got IE real quick?
IE,
Yes.
basically, if you're looking here, VE right here, IE here. So they connect to the route. So basically, you just take VE, divide IE. That's how we calculate IE.
Okay, I was a little confused because on the previous slide, it says IE equals VE divided by IE.
RE. Sorry.
Oh, so it's RE. Okay, so yeah, on the previous slide, I think there's a mistake.
Okay, anything else? If not, we go. Okay, this one. This one we already calculate for you, but I just try to explain how we do calculation. On this one, they're using the PNP. Okay, you see the arrow coming in. And when you see the arrow coming in, they must be at meter. Okay, at meter by collector. And now they want VBB right here, same thing. Okay, you take 10 volt times 22K divide 10 plus 22K. This is the calculation. I already given you the formula here. Okay, you can get the substitute the value. You can get the answer. Okay, and now after you get the voltage here, they want to calculate the VE right here. VE here means you will be measured from E to the route. Okay, from this VB to the route, you already calculate on number A right here. So in order to calculate the VE, you take that voltage adding to 0.7. That's what number B. VE equal 0.7 adding to VBB. Okay, and now you need to do calculation for IE. This IE right here. You know this side VC, VEE, this side VE. So you take the difference between the two voltage divide to RE. That's number C. IE equal VEE minus VE divide RE. That's a difference from NPN. So now, if you want to calculate the VB, same formula. Take IE divide beta plus 1. And also you want IC, then will be same thing, IB times beta. And now you want to calculate the VC right here. VC means from collector to the route. You already get the current IC right here. Then VC will be equal IC times RC. And if you want to calculate the V from E to C, VEC, they will be equal VE minus VC. You already know VE. You already know VC. That's why you're able to calculate the VEC. Okay, any question in this problem? Just bring it up. When you're doing a quiz, you will be see that kind of problem. Okay, only thing is, I want you to do it without looking into any formula. That's what you need to exercise. Okay, now another difference for P and P. In this one, they're using a negative voltage. Okay, and if you're looking on this one here, then you need to know that will be S-meter. That will be collector. Okay, so if you want to calculate the voltage here, same thing, voltage divider. I give it to you here. Now, you want to calculate the VE. Okay, you already get the VBB. That will be a negative voltage. Okay, they will be a negative voltage. The thing is, right here, you get a negative. Okay, so VE will be equal to VBB plus 0.7. Remember, VBB negative voltage. And if you're going to calculate the IE, that means the current flow here, then you can take your VE divide IE. After you get the IE, you can calculate IB the same way, IC the same way. And VRC, that means the voltage here, drop across RC. Then you can see IC times RC. And now, if you want to calculate the V at the collector, will be VCC plus IC times RC. Not minus. Minus that for NPN. This is the PNP. Okay, any question? That's only 3 configurations. We're asking you. Try to do it right away when they need a calculation. Okay, now we're talking about this thing. Capacitor. For the capacitor, normally you can see when you connect the AC circuitry to the capacitor. And the capacitor will be get a resistor. Okay. And that resistor will be calculated by the formula 1/2 pi FC. But they not call a resistor. They call a capacity. Reactant. In this formula, HC will be in ohm. That means they just write like resistance. However, for the capacitor, that resistance will be called capacity reactant. Okay? And now, in this formula, if F equals 0, okay, F equals 0. Oh, tell me what HC equals.
It's infinity.
It's infinite.
1.
1/0.
1/0 equals what?
Infinity.
Exactly, infinity ohm. When they equal infinity ohm, what that means? No current can be flowing. All right?
Open.
Okay. So F equals 0 Hertz. That means for the DC. Okay. So HC equals infinity ohm. That's only telling you capacitor open. Okay. That means for the DC circuitry, capacitor will be open. That means when they full charge, they not allow any current flowing through the capacitor anymore. They open. However, for AC, what frequency you want it to be? For
60
the
hertz.
AC circuitry, what frequency supposed to be?
60.
60 hertz.
You can say 60 hertz. The other one can say 1 kilohertz or 10 kilohertz, 100 kilohertz. So I want to select F equal infinity hertz. That means you cannot make it bigger. Okay? So if you calculate the FC, HC, 1/infinity.
0.
1/infinity, you get 0. That's just a math. They get a 0 ohm. So that will be telling you 0 ohm means they shorted. So what we need to come up with, the capacitor for DC, they will be open. However, For the AC, they just lay the wire, they short it. Okay? That are very important. Now, on this display here, good coupling. What that mean? You understand when they say good coupling? Okay? That only telling you if you get a sideway on this side and you get the sideway on the other side, this sideway are almost the same thing. That means capacitor in a good coupling. So anyone design the circuitry, then they have to be using the formula. Okay? This formula, Hc equal 0.1 of resistor, right here. Okay? So depending on what resistor, they have to select the value for Hc. Have to be less than 0.1 R to get much better coupling. That means you get a signal from one side of the capacitor and the other side. They're supposed to be almost identical. Okay? The next they show you is shorted. That means you get a sideway here, output coming out this side, they're supposed to be the same sideway. They allow the sideway to go. Open, when you get a DC here, okay, then the capacitor, they will be open. That means they not allow any current DC flowing. So that's why when you're working on the oscilloscope, you need to set the coupling, AC coupling or DC coupling. Okay? If you set it to the DC coupling, what happened on the oscilloscope? When you're looking on the oscilloscope, if you set the scope in DC coupling, what they're supposed to be displayed on your screen.
DC voltage only.
You say DC voltage. Who else?
DC plus the AC on top. Isn't it?
Exactly. In general, when you set the DC coupling, on your scope, they will be displayed both voltage, DC and AC. Okay? If you set your oscilloscope to the AC coupling, then they block the DC. They display only AC voltage. That's a very, very basically technician must to know. Okay? Now, we're talking about amplifier. That will be performed complete DC analysis. That means before you want to doing on the amplifier circuitry, you have to do on up the DC calculation. That means you have to know what the IB, IE, IC, VB, VC, VE. Okay? Next step. Short on the coupling. and bypass capacitor. Okay, that means you see the capacitor, they will be shorted. Okay. Visual on DC supply voltage at the AC route. That means on the AC circuitry, you will not see any DC voltage. That DC must be grounded. Replace the transistor by pi or T module. They get a different module represent for the transistor in the AC circuitry. And draw the AC equivalent circuitry. So basically that normally for engineering, okay? But at least I try to see how many students can understand when you try to deal with the AC. Otherwise, normally they just given you the formula and you're able to calculate it. Okay, any question on this step for the amplifier? You want to analyze amplifier circuitry, then you must be following step by step. Okay, now they given you the T module of the transistor. So basically, you can see that transistor normally you see. Okay. However, in the AC, they substitute by this form in this formula here. Okay. That means from the collector, you get the current flowing down. Okay. At the base, you get the current IB, IC, same thing. Okay. However, for the AC, we're using the lowercase letter, uppercase for the DC, lowercase for the AC. Okay. And now you can see a difference in the AC module from the base to the ammeter. You understand, for in the DC, you get a diode. However, for AC, they substitute by the resistance R prime E. Okay? So basically, in the AC module, you don't have any diode here. They will be resistant. Okay? And they can count telling you G in base. What that means for G in base? How many students can understand when they're talking about G in base?
Entrant impedance.
Try to get something clear, someone can understand. J in base, basically, sometimes same thing with R in base. Okay. Sometimes they're using R in base, sometimes they're using G in base. What that mean?
Z is the impedance. Same thing as resistance.
If I given you the meter, I say, okay, I want to measure the R in base or J in base. How can you connect your meter? High side where, low side where? R in base mean resistance from base to ground. That means when I talking about RB, R in base, that means they talking about the resistance from the base of the transistor to the common, to the ground. That is the definition. So if you measure to connect the high side to the base and the low side to the ground, set the meter to measure resistance. That's what you will get the J in base or R in base, okay? And now VBE, okay? What the VBE? Right here. You know that a voltage. Voltage from where to where?
Base to emitter. Base to emitter.
Base to the emitter, correct? Okay, you can see VB mean the base, E mean emitter. That means the voltage from here to the here. This is the emitter, okay? And we calculate by IE times R prime E. And now they can give it to you. J in base equal IE times R prime E divide IB. Okay, then they substitute IE equal beta plus 1 times IB, they cancel IB. Finally, the formula here. In order to calculate the resistance from the base to the ground, you're using the formula beta times R prime E. Finally, R phi E for the transistor bipolar. They're using formula 25 millivolt divided to IE. So when you, even you don't have to do anything with this thing. The thing is that for designer. However, try to understand as much as you can. In the interview, they asking the question for the AC signal.
Can you explain can you explain the 25 millivolts? Where does that come from? Is
That's
that
coming from the data. That's from manufacturer.
okay?
Okay.
So that's not anywhere in the model. It's
No,
just
no.
It's coming from data sheet, right?
Yeah. For interview, they can asking you. Is it again what represent for the diode from the base to the X meter? That means for AC, you don't have any more diode. That will be substituted by the resistance R by E. And that resistance will be calculated by 25 millivolt divided to IE. Now, this just given you general formula. You get the amplifier with the gain equal 200. So the gain equal the definition ratio between output and the input. That is the gain. Okay. You take the output, you divide by the input, you get what they call the gain. Okay. First one, we get the circuitry amplified, we call a common admitter. See how many more we get. You get a common admitter, you get a common collector, and you get a common base. Okay, you understand for NPN. Then easy for you later on understand the JFET. They will be almost the same. Okay, so the first configuration we learning common admitter. That's what they call a CE amplifier. So you don't have to design it, but when you're looking into the circuitry, you have to know, is it a CE amplifier or CC amplifier or CB amplifier? So if you're looking into the circuitry, first thing, input your void right here will be applied to the base. That is the input applied to the base. Output, this is the output here, will be coming out from collector. That's a very important. Okay. Input applied to the base. Output from collector. That's what we already telling you here. Input applied to the base, output collector. Okay. And they said also input output 180 degree of phase. That telling you if you get the input in a sideways, output they also sideways, but they will be 180 degree of phase. Opposite. That is what you need to know. Okay. And now we need another definition. First thing, C1. If you're reading, you can see C1, DC blocking, AC couplet. What that mean? That means you get your sideways on this side. They allow sideways on the other side. Any DC voltage from the input, they will be blocked by C1. Why? The thing is when they amplify it, they amplify your voice. Okay? So that's why they need that C1. They block any DC coming from the input, only AC they let go. So the name after C1 will be DC blocking AC coupling. Okay, at the output here, C2. Okay, at the point collector here, you get 2 voltage. One will be DC voltage, and another one, they will be the sideway AC voltage. Okay, and they go to the load here, that means the speaker right here. You don't want any DC going to your speaker. So that's why they need capacitor C2. Okay, this capacitor C2 here, they will be block the DC from the collector to the output speaker. And the name on C2 will be the same like the name on C1, DC blocking AC coupling. They block DC, but they allow AC to pass. And the last C3 right here, the name they say bypass capacitor. This name is bypass capacitor. How it works? Why they get the name bypass? You understand it for AC, this will be shorted.
AC
Right.
into a short. Exactly.
It's shorted, just like the wire. So
Exactly.
basically the current at this point, they not go here. The thing is when they short, they go to the short to the route. Okay?
Yeah.
So that's why they say bypass capacitor. Question is, bypass what?
AC
RE.
RE.
Bypass RE.
to I.
The thing is the current AC, when they go up to this point, they're not going down here. They go shorted to the route. So if you measure the AC voltage at this point, you're supposed to get route 0. Okay? The thing is they short to the route. That's what they call bypass capacitor. Okay? And now, the purpose of the bypass capacitor. If you get the bypass capacitor and the gain of your amplifier will be increased, okay? Without the bypass capacitor, the gain will be lower. That is the purpose to get the bypass capacitor. So, when you're looking into this circuitry, you must know that is a common ammeter amplifier. That is the first. Second thing, input will be applied to the base. Output will be coming out from the collector. And the next will be input, output will be out of phase. That means they will be opposite. Input positive, output negative. Input negative, output positive. Okay? And on of the capacitor, you must know the name, the purpose of its capacitor. Like C1 or C2, that's what we call DC blocking or AC coupling. And the C3, that's what they call a bypass capacitor. We need a bypass capacitor if we want the gain of the amplifier will be higher. That is a summary. At least that's what you need to know about the CE amplifier. Okay. Now we'll see. This is what really technicians need to know. Okay. On that one here, you can see 10 volt DC, 3.6K, 2.2K, okay? And now you can calculate a voltage divider. You can get voltage right here, 1.8 volt. That's a DC. You calculate the DC, you get VE 1.1 volt. And you get the VC 6.04 volt. That's all of the calculation for the DC. We already done. Okay. And now you apply 100 microvolt sideways. Okay. So sideways here will be go to the base. So at the base, you get two signals. One will be 1.8 volt DC, and another one will be a sideways, and they will be displayed on the oscilloscope. Look like 1.8 volt here, and this is your sideways. Okay. So if you want to measure sideways at this point, your oscilloscope will be set to which coupling, AC coupling or DC coupling.
AC.
If you're looking on this circuitry and they're asking you to measure the AC signal at the base on your oscilloscope, what coupling you supposed to be set?
AC.
or
AC. AC coupling blocks the DC.
You set AC coupling or DC coupling?
No,
AC.
AC, I said the DC will be blocked from the AC coupling. So use AC.
You must set to AC coupling.
Yes, correct.
Why?
Because it blocks the DC.
Yeah, I understand. DC AC coupling means they block the DC, but I want to know why you want that block.
Because you want to measure only the AC.
The value of AC is a lot smaller compared to DC.
Correct.
So therefore, if you do not block DC, you won't be able to see the AC.
Exactly. That is really understanding. If you set a DC coupling and you can see the DC is too big and the AC will be too small, so you cannot see the AC like they show you in here. Okay. The thing is that AC will very, very small. You cannot measure. So that's why you must set AC coupling to block DC 1.8 volt, they display only AC that you're able to measure. When you're working on the transistor circuit board, that's what you hit into it. Okay, so if you measure the AC at the meter, you're supposed to get 0, the thing by part. Okay, so same thing when you measure at the collector here, you can see this is your sine wave and the 6.04 DC voltage at the collector. Okay, and now you compare to the input, this going up, this going down. Okay, they opposite with the input here. Okay, so output here, now you can see output here, you get a 0 volt DC, and this is your signal. The reason is you get a 0 volt DC, the thing is C2 will be blocked 6.04 volt. You get only AC to your speaker here. Okay, that is how show you how the signal will be displayed on each point in this circuitry. And these are important for you. The thing is, when you get a sine wave in, you measure here, you're able to measure the sine wave at the base, and you measure at the output here, you get the sine wave at the collector and also at the output. That is required for technician. You don't care what's going on, how they can do it. But that is basically you must know. Okay, any question up to this point? Also, they call a common admitter. Why they call a common admitter? Tell me, why they call a common admitter?
The input is at base, output is at common, and then the emitter is the base for the two signals.
That's why. Common admitter. You understand common? Round, right? Common is like the round.
Yeah, because it's connected to the ground.
Common admitter. That means in a common admitter amplifier, admitter will be round. Right now we display the signal for you here. That including the DC. Okay? That's not a circuitry completely in AC module. That is what normally you have to deal with. However, when they say common admitter, that means in the admitter CE amplifier, admitter will be round. Common collector, that means in the common collector amplifier collector will be ground. Common base amplifier, the base will be rounded. Okay, now you can see this is the T module of the common emitter. So if you're looking into this module here, so you know this is the base. This is the collector. This is the emitter. So basically from the collector go to the emitter here, they get only one current. They will be IC. You already know IC equal beta times IB. However, this will be AC. Okay? Current IC will be AC. And also at the emitter. Now, first thing I want to say for the AC module, they're telling you this 10 volt right here will be connected to the ground. Okay, that's what we already talked at the beginning. For the AC module, DC voltage will be rounded. So at the collector right here, first thing, capacitor will be shorted. Okay, shorted. So if you're looking at the collector, what you see you can get. First thing I can see, I can get the RC right here. One side connect collector, the other side connect to ground. And also I get another resistor right here, RL, the load. One side connect to the collector, the other side connect to the ground. So that's why you can see right here. At the collector, you get RC, connect collector, ground. RL, connect to the collector and ground. Okay, that is the output. Now at the input, see what you get. R1 here, connect to the base and connect to the ground. RC, connect to the base, connect to the ground. And also the capacitor here shorted. Okay, so you can see at the base, you get R1 connect to the base and to the ground. RC connect from the base to the ground. Okay, and also in the emitter. Okay, sorry, that emitter right here. This is the emitter right here. Okay, from the base to the emitter, you get resistance R prime E. Okay, and this resistance equal 25 millivolt divided to IE. Okay, so this is the emitter. So now you can see emitter rounded. That's why they call common emitter. That means in the AC, at meter will be rounded. Okay, so what do we need to know about this amplifier? First thing, if you're looking from output into the amplifier, that's what they want to know, what is the output resistance. So when you're looking from the output go into side the amplifier, what the out supposed to be? The out sometimes they using RC. R small, that means AC resistance. So what you're looking into that, what you say, what you get. You can get RC, RL in
Parallel.
parallel, right here. They already give it to you. So if I want to calculate the output resistance, then you take RC parallel with RL. RC times RL divide RC plus RL. That is what the first thing they want. The second thing they want, input impedance. That means you're looking from your input here, looking inside. That's what they call input impedance, the in. Okay, that is the input impedance. So what you supposed to see?
R1, R2, RE in parallel.
R1, okay, R2 in parallel, that's correct. However, you cannot count on this R prime E. This inside the transistor, not outside. But you will be see another one. That's what they call RB. Okay, what that mean? RB. What is it?
That's a base resistance
That means the base resistance.
for AC.
Yeah, that means the resistance from the base to the ground. Okay, base resistance. By definition, what are be supposed to be equal? We don't care much about circuitry, but I'm talking about the basic definition. What are be equal?
VV over IV.
Exactly. That's a very good. Basic, that's a basic Ohm law. You take the VB divide IB. Okay. How do we calculate that? Will be coming later. But if I'm looking here, input impedance, input impedance, that means if you're looking from your input to the amplifier, how much resistance you see, then now you can say R1 parallel R2 parallel RB. That means you can get this one parallel to this one, parallel to this RB right here. Not RE, R prime E, no. This inside the transistor. Okay?
Okay.
Any question? Not easy, right?
Mhm.
I understand. So, we'll continuing tomorrow. The thing is, sometimes you go through one time. No, I don't think you understand. Second time, maybe. Third time, maybe better. Would you try to memorize, understand like I did it, then you okay. Perfect technician. Okay, any question? No?
Questions on the third, maybe.
Yeah, I have to review this a few times, watch it on YouTube.
Okay, so anyway, good night. Okay,
Good night.
yeah. Good.
Leslie,
well,
quick
thank you.
question for you, Professor. Could you go to slide 21?
What do you mean 21?
Slide 21, yeah.
It is 31. You want,
No, 21.
2-1.
yeah. 30.
I just want to get clarification because I know we're going to have a quiz on it,
Okay, let's see.
on the voltage divider bias.
23.
21.
21 here.
Yeah, so you see how it says, and when the formula is IE equals VE divided by IE,
Right.
the IE should be RE, right?
Yeah,
should be-
yeah.
I just want to make sure because
Yeah,
I know
that's
we're going to
right.
have a quiz on that.
Yeah, VE over RE.
Thank you. Typo.
Okay,
Mr. Pham got to do an update.
Right. Correct that later.
okay, perfect. Thank you.
Thank you. I have to thank you. Otherwise, a lot of people get a problem when they're working on quiz.
Yeah, I want to be able to pass the quiz, so
Yeah.
just have to make sure that was right. Thank you.
Next time you guys see something confusing, bring it up right away. When you're asking later, I telling you VE divide RE, but I don't understand. On the display, VE divide IE get dropped. Okay, thank you.
Okay.
Okay.
So good night.
Good night.
99.
Okay,
Good night. Thank you.
Good night. Thank you.
good night.